This is the Senior Design 2 poster for Siemens HD9. The objective of this project is to design an adjustable fixture stand that will be used to hold different size exciters and rotor parts that will be machined on a horizontal milling machine. The fixture stand must be able to be adjusted in 4 different directions to precisely center the part on the cutting surface. The precision must be within 1/1000th of an inch.
Our prototype design features a few key design elements, starting with the ball screw jack assembly, which is comprised of a high-power servo motor, a high-capacity ball screw jack, and the two of those are tied together with an elastic shaft coupling. Next we have the linear rails, which constrain the motion to a single axis and provide stability against perpendicular forces and any kind of potential moments. We have the ball screw stage for the horizontal adjustment, and that is driven by a high-power servo motor, and also features a high-capacity ball screw stage. The two of those are tied together with an elastic shaft coupling. For controls, we have a Siemens PLC, Siemens motors, Siemens motor drivers, and a hand pendant from Siemens as well. The pendant would be providing instructions to the PLC on how to drive the motors. We also added an e-stop in an emergency event that the motors do not respond to the pendant. You can stop the motors manually. For safety, we added a plastic cover over the horizontal adjustment motor just so no one trips over it and doesn't notice it's there. And we also added a sheet metal guard in front of the V-block to minimize the threat of pinch points.
For the full-scale model, we had a cabinet that includes an HMI, a PLC with an input and output module, 2 servo drivers, and an emergency switch. For the prototype model, we had an LCD screen with a knob, a main board, and a power supply. On the right, you could see the main board that was used in the prototype model, and right below that, we have the servo motor driver and the servo motor.
Here is the bill of materials for the prototype design. It includes the different components needed to create the design. The overall cost of the bill of materials was around $65,000 due to the complex nature of this design.
Here are some key design elements of our kinematic prototype design. Our prototype ranges between a 1/4 and a 1/6 the scale size of our original design, and the majority of these parts are machined aluminum to represent key components in the prototype. The ball screw jack represented in the original design has been replaced by a machine screw jack that was procured from McMaster. And stepper motors have been replaced, and instead of the original design had servo motors. And below you can see a 3D model of our kinematic design.
Here are some photos taken during the fabrication process of the kinematic model. The top left picture shows Zane Rodman drilling holes in the rail bases. The top right shows holes being drilled in the support plate. The bottom left shows the assembly phase of the design. The bottom right shows facing off the rail bases to make a smooth surface. And the middle photo shows testing the assembly for functionality.